Okay, the next part about waves that we have to look at is this idea of energy. So we've talked about how waves are movements of energy. And so with this idea of energy transfer is that the first thing that they're really, really efficient at doing this. So one of the big ways that we measure the energy of a wave is to look at the amplitude. Okay, think about it when you go to Galveston. The taller the wave is, the more energy it has, the more easier it is to knock you down. If you watch waves during like a tsunami or a hurricane, those waves are huge. Okay, and they carry tons and tons and tons of energy. So that's another way that you can look about it. The other way to think about it is if you think back to the person doing the wave in the stadium. You always get those people that just move their arms up and down, okay, that are like, okay, whatever, I'm here. And then you get the people that are sitting there waiting for it, and jump up all high, okay? It takes a lot more energy to jump up and do the wave than it does just to move your arms. So the bigger the wave is, the higher the amplitude, the more energy. The way that we look at this, though, is that your energy is actually proportional to your amplitude squared. So if you double the amplitude, your energy is actually going to quadruple. Okay, so if you jump from going from 2 centimeters and now you jump 4 centimeters, that actually takes 4 times the amount of energy that it did. Because you have to think about it. Remember, you measure the amplitude from the nodal line or that equilibrium line up or equilibrium line down. So since you have to account for both the ups and the down, that's why it's a quadruple. Okay, so if we look at that from a practice standpoint, if a wave's amplitude is tripled, how is the energy going to change? Okay, so we're talking the amplitude is tripled, so it's going to be 3 squared. So your energy, this little apostrophe right here just means the new energy. It's prime. So your new amplitude is going to be 3 times the original amplitude. Plug it in the equation, and again, you're talking about that it's going to be that amplitude squared. So that means that your energy would be 9 times as great. Okay, just by tripling it. On the flip side of it, if the amplitude is cut in half, again, you're looking at this square. So if you halved it, your new energy is going to change by 1/4. Because you're doing 1 over 2 squared. 1 squared still stays as 1. 2 squared becomes 4. So if you cut the amplitude in half, your energy is now 1/4 of the original value.